Okay, what's happening today?
We're rotating about the y. That means we're going to have to make functions in terms of y.
Yes,
No.
we are rotating about vertical axes now. Okay, which means, okay, as you can see with my picture, our washers are going to have thickness dy. Right? We're going to take a chunk, we're going to rotate it around, and these are going to have thickness dy. Okay? Now, obviously, the washers that I have in my hand aren't infinitely small, right? But maybe the idea. Okay? If we are integrating with respect to y, that means our functions need to be solved for x. So everything is in terms of y. Okay? Are there situations, okay, when we did area, were there situations where it was easier to integrate in terms of y?
Yeah.
Okay. We will eventually learn a second method, okay, where we'll, for volumes of revolution, okay, so like next week we'll get to make the decision whether it's going to be easier to do in terms of x or y, but as far as the disc washer method, we're rotating it about a horizontal axis. We've been doing it with respect to x. Around a vertical axis, we're going to do with respect to y because of our rectangle.
If you revolve it about the x and not the y, do you get the same answer? No?
Only if it is
Oh.
symmetric
Over y equals x.
over y equals x.
Okay.
Yes. Okay. Okay. So, like we did yesterday, if we talk about these washers, they have volume pi r squared h minus pi r squared h, right? But now you see that our thickness is dy because we have horizontal rectangles, okay? And so we are going to integrate pi r squared h minus pi r squared h, basically. Okay, be careful because now that we're integrating with respect to y, our limits of integration will need to be our y values.
Yeah.
Okay, are we ready? Good. Okay, this is one we're not going to need a calculator for. Okay. We have y equals 2x squared, y equals 0, and x equals 2 about the y-axis. 2x squared, okay, here's y equals 0. Here's the, okay, what? So here's x equals 2. It's a parabola with a vertex at 0, 0. What about when x is 2? So we have this portion right here. Do you agree with my drawing?
Yeah.
Okay. Now we are going to rotate this around the y-axis, which means we're getting something that looks like this. Except, right?
Yeah.
Okay. Now we are rotating these rectangles with thickness dy. So we're actually getting something that looks like my speckle of rings here, right? These washers where the hole is around the y-axis. Okay, so this yellow thing's my y-axis. Right? Okay. So if we're integrating with respect to y, let's first change this equation in terms of y. Right? So we're going to need to solve for y here. Solve for x. Right? So x would be plus or minus radical y over 2. Which portion is this? The positive. Right? Okay. So let's set up our integral. We have pi r squared minus r squared h. We have washers. So let's talk about our large radius. Okay, this is our axis of rotation. The furthest away would be here. What is that distance? 2. This is a vertical line. Vertical line to the y-axis is just 2. Okay. Our inner radius would be axis of rotation to here. Okay, positive radical y over 2 squared. 0 to 8 because we're in respect to y. Yes, be careful. Okay, do you see where this could start to get a little confusing? Okay. Okay, you're just going to have to be very careful, go slow, pay attention, okay? Double check your work, okay? Now once we get it set up, the rest is easy, right? This is 4 minus y over 2, right? Antiderivative of 4? Good call. Minus antiderivative of y over 2?
Be 1/2 y, so that'd be 1/4 y squared.
Okay. So when we plug in 8, we get 32 minus 64/4.
That's 16.
What? Oh. And then when we plug in 0, we get 0, right? So what's our answer?
16.
Nice. That would be a beautiful non-calculator question, okay? Because it's easy to integrate. Okay. What? Okay. Let's try another one.
Calculator?
I don't think we need one. Okay, let's talk about the region. Square root of x and y equals x squared. Where are those going to intersect?
1, 1.
Right, this probably keeps going, but it doesn't matter, right?
Yeah.
Okay, so there is our region. We're going to draw horizontal rectangles so that when we rotate it about the y-axis, we are going to get washers.
Would that be the same if you just took it on the axis? Yeah, like it would be the same.
Let's test it out. Would you like to do that? Okay. So let's do this first. Jared thinks yes because of the symmetry, right? All right, so first let's do about the y-axis. So we have, do we have washers or discs? Washers. So pi R squared minus R squared H. Okay? Outer radius. Our largest radius is from our axis of rotation to
One
this.
Square root of y.
So from right to left, this is just
half radical y over two.
Positive square root of y.
this is our parabola, right?
Yeah.
So isn't it just plus or minus radical y? And this piece would be the positive. Okay. This equation right here, okay, our inner radius is from axis of rotation to y squared, so y squared minus 0 is just y squared. Why did I say y squared minus 0?
Because from the axis to itself is 0.
Okay, good. Okay, because the axis is what our point of reference is, right? That's our axis of rotation. So, and what are our limits of integration?
Before we start, I think it would be the exact same equation for x. No, because
Yeah, so it'd be the square root of x.
Okay, let's go over here on the whiteboard. Sorry, those of you watching at home. This is radical x, and this is x squared. If we rotate this about the x-axis, we're rotating towards vertical rectangle so that we get washers. So we would have pi r squared minus r squared h. Our outer radius
Square root of x.
is from here to here, right? And that's square root of x. Our inner radius and our limits of integration. Look at that. It is because of the symmetry. Okay? This is a rare case. All right?
Why would they not be equal symmetry?
Because then you could have different limits of integration.
Well, think about, here, let's go to this picture right here. Think about if I did this picture. When we rotate this, we're getting something that looks like this.
Oh, okay, yeah.
Okay? When we rotate it like this, we get like a cylinder with a bowl cut out of it, right? Okay. Beautiful. Not gonna work over there. Okay, we can integrate this, right?
Yep.
Okay. We have time. Antiderivative of y minus antiderivative of y to the fourth. Evaluated from 0 to 1. So we have pi times 1/2 minus 1/5 minus 0. So we get
2/10, which is 1/5.
what?
Right? No, that's wrong.
3/10.
3/10, yeah, my bad.
Okay. What haven't we done?
Over a line that isn't the y-axis.
Over y equals x.
We're not gonna do that.
You're safe.
Okay. Let's take this same region and rotate it about x equals 10.
That's a long way away from the intersection.
Yeah.
You make that one equal
We've got some big washers, don't we?
Yeah, we do.
Okay. So here I will draw in my horizontal rectangle that we're going to rotate around to make washers. Okay. We have washers, so we have pi r squared minus r squared h. Radius, that is the biggest. Well, we always go from our axis of rotation to the farthest away. So that would be from here to here, right? When we talk about distance, vertically we go top minus bottom. Horizontally we go
Left minus right. Right minus left.
right minus left. So what's the very most right?
10.
10 minus
Y square root of 1. Square root of 1. Y squared.
right?
Yes.
Okay. And then our innermost, or our smaller radius, here's our axis of rotation, to here would be what?
Square root of 1.
Okay. This would definitely be one that would be messy algebraically, don't you think?
Yeah.
Okay. Doable? Yeah. But
It wouldn't be fun.
let's talk about rotating it along.
The axis to the left.
Yes, pick a number.
Negative 7.
We'll do, I heard -7 first.
Y equals 2x plus 4.
Oh,
And this line shift.
okay.
It's such a good thing. Gosh, they didn't make that over really frustrating.
Okay, you know what, I better do
Yeah, let's do
-3 because
Yeah.
I didn't draw it big enough.
I thought we were going to need something, so I remember actually
Okay. So here's our rotation. Remember, this is the one we're rotating, so that is where the rectangle gets drawn.
Yes,
Thickness dy. Now we have these washers that we're twisting around, so we have pi r squared minus r squared h. Okay. Our biggest radius is from our axis of rotation to where?
square root of 1.
Okay. And how do we describe that distance?
The square root of y plus 3.
Okay, so this is the square root of y, because that's the very right, minus -3. So we say that's the square root of y minus -3. Right? Our innermost radius is from our axis of rotation to the closer function. From right minus left, we have y squared minus -3. Okay? Right minus left, top minus bottom. Right minus left, top minus bottom. Okay? You have to remember that. Okay? For all of these problems that we do. Okay? This week and next week.
Are we gonna do it about not horizontal vertical?
Nope.
That BC.
Nope.
Never.
Never.
Is it possible?
There's gotta be a way.
Do you know?
If there's not a way yet, then me and Jared will figure it out and become geniuses.
You don't just become geniuses. You're either born a genius or you're
No,
not.
once we figure it out. then-
Hey, not with that attitude.
No, that attitude,
I
bro.
don't plan on becoming a genius. I'm okay with that.
It's like saying you're not born to be excellent in sports.
Okay, everyone hold that thought.
It's like you are.
You're born to be excellent for another sport.
Okay, I'm boxing the ones that I want you to do how?
Okay.
No calculator.
Can we rotate it about